The topic is proportions. The objectives in this topic are write sentences as proportions, determine whether proportions are true, and find an unknown number in a proportion. A proportion is a statement that two ratios or rates are equal. For example, 5 is to 6 as 10 is to 12. That's how we say that. Good old analogy format. 5 is to 6 as 10 is to 12. Ratio equals ratio, or rate equals rate. So let's write the statement 12 diamonds is to 15 rubies, as 4 diamonds is to 5 rubies as a proportion. Well, 12 is to 15 as 4 is to 5. Notice the number of diamonds is the first number both times, and the number of rubies is the second number both times. To determine whether proportions are true, we can check cross products. This was the same method we used to determine whether fractions were equal. If a proportion's true, then the fraction-looking things are equal. So we take products of the diagonals. A times D, B times C. If they're equal, the proportion is true. If they're not equal, the proportion is false. So we're going to be checking some proportions. Is 4.1 to 7 equals 2.9 to 5 a true proportion? In other words, are these fractions equal? Take the cross products. We'd have 4.1 times 5. We'd have 7 times 2.9. 4.1 times 5 is 20.5. 7 times 2.9 is 20.3. They're close, but they're not equal. So it is not a true proportion. We're going to be reviewing how to multiply all sorts of number types in this topic. Here we have mixed numbers as the numbers in the 4 positions of the possible proportion. So when we take cross products, we need to multiply the 2 1/3 times the 3 3/10, and we need to multiply the 1 5/6 times the 4 1/5. In order to multiply mixed numbers, they have to be improper fractions, so we convert them all to improper fractions. Feel free to pause and try this on your own and see if you get the same answers. But these are the improper fractions. 10 times 3 is 30 plus 3 is 33/10. 5 times 2 is 6 plus 1 is 7/3. 6 times 1 is 6 plus 5 is 11/6. 5 times 4 is 20 plus 1 is 21/5. When we multiply these, you can break these up. 21 is 7 times 3. 6 is 3 times 2. The 3's cancel. The 33 is 3 times 11. The 3's cancel. That's 11 times 7 over 10. Here, also 11 times 7 over 10. 77 tenths. 77 tenths. They are equal. This is a true proportion. Did you try that one on your own? How'd you do? Nothing new except checking cross products, and we've even done that. So this is just putting everything together with a new use, finding unknown numbers and proportions. When one number of a proportion is unknown, we can use cross products to find the unknown numbers. So if we know it's a proportion, then the cross products are true. They are the same. So if we set the cross products equal to each other and then solve for the unknown number, we should be able to get it. Take the cross products. Negative 15 times x, 60 times 2. Set them equal to each other. And then just solve. Simplifying the left, we get negative 15x. Simplifying the right, we get 120. Solve for x. Divide both sides by negative 15. Positive divided by negative is negative. X equals negative 8. Solve for n. Well, if this is a true proportion, then the cross products are equal to each other. So take the cross products and set them equal to each other. 51 times n equals 34 times 3. Simplifying the left, we get 51n. Simplifying the right, we get 102. To get n by itself, we need to undo multiplying by 51. That's going to be dividing both sides by 51. And 102 divided by 51 is 2. Fractions. Doesn't change what we do. Take the cross products and set them equal to each other. 7/8 times 4/7 equals 2/3 times z. Over here, the 7's cancel, leaving us with 4/8, and 4/8 reduces to 1/2, so 1/2 equals 2/3 z. To get rid of multiplying by 2/3, we multiply by its reciprocal, 3/2. So 3/2 times both sides gives us 3/4 equals z. Solve for y. We have decimals. Doesn't change what we do. We're going to take our proportion, and since it is a proportion, that's a stated equality, we know the cross products are true. Set the cross products equal to each other. 1.2 times y equals 9 times 0.6. Nine times 0.6 is 5.4. Divide both sides by 1.2, and we get y equals 4.5. Mixed numbers. Take the cross products and set them equal. I sound like a broken record because I am a broken record. It's the same process every time. Take the cross products, set them equal. In order to multiply mixed numbers, they need to be improper fractions. 5/3 times 13/5 equals 13/4 times n. That's 13/3 equals 13/4 times n. Multiply both sides by the reciprocal of 13/4 to get rid of it. So 4/13 multiplied on both sides. And we get n equals 4/3. And technically, we really should say 1 1/3 because of all of the other mixed numbers in the proportion. So this is just pointing out that dividing by 13/4 is what gets rid of multiplying by 13/4. But dividing by 13/4 is multiplying by the reciprocal. And that's why we just multiply by the reciprocal. That's what's working in the background when we do that. And that's it for this topic. The topic is proportions and problem solving. The objective of this topic is solve problems by writing proportions. On a Chamber of Commerce map of Abita Springs, 5 miles corresponds to 2 inches. How many miles correspond to 7 inches? Well, we have these two comparisons of miles to inches. 5 miles is to 2 inches, as an unknown number of miles is to 7 inches. So if we do miles over inches equals miles over inches as a proportion, one side would be 5/2, 5 miles to 2 inches. The other side would be n/7 or x/7, an unknown number of miles to 7 inches. Once we have the proportion, we can solve it. Since the proportion is a stated equality, we know that the cross products are equal. So we set the cross products equal to 0 or equal to each other. 5 times 7 equals 2 times n. That's 35 equals 2n. Divide both sides by 2. N is 35 halves, or 17 and a half. So 17 and a half miles is what 7 inches corresponds to. The standard dose, that should say dose, not does, of an antibiotic is 3 cc for every 50 pounds of body weight. At this rate, find the standard dose, there we go, for a 130-pound woman. So 3 cc's for every 50 pounds of body weight. We can set up a proportion in cc's over weight, cc's over pounds. And one side would be the 3 cc's for every 50 pounds of body weight, 3 to 50. On the other side, we have an unknown number of cc's, which would be the standard dose for a 130-pound woman, an unknown to 130 cc's to pounds. Take the cross products, set them equal. 3 times 130 equals 50 times n. That's 390 equals 50n. Divide both sides by 50 to get the n by itself. We get 390 over 50, which is 7.8. Therefore, the standard dose for a 130-pound woman is 7.8 cc's. A 50-pound bag of fertilizer covers 2,400 square feet of lawn. How many bags of fertilizer are needed to cover a 2 square? Sorry, I'm just trying to figure out what on earth a 2 square is. How many bags of fertilizer are needed to cover a 2 square containing 15,360 square feet of lawn? Round the answer up to the nearest whole bag. I even Googled it. It's not a thing. Not a page one Google thing, at least. So we can set up a proportion, bags per square foot, as the form of each side of the proportion. The first sentence tells us that one bag, be careful not to say 50 bags, one bag covers 2,400 square feet. So that's the left side of the proportion. An unknown number of bags are needed to cover 15,360 square feet. So that's the other side of the proportion. N to 13,360. Take the cross products, set them equal. 1 times 15,360 equals 2,400 times n, 2,400 times n. 13,360 equals 2,400 n. Divide both sides by 2,400, and 15,360 divided by 2,400 is 6.4. Now we want to round the answer up to the nearest whole bag because you can't buy 0.4 of a bag. So 7 bags of fertilizer are needed to cover the 2 square, whatever that is. And that's it for this topic. The topic is square roots and the Pythagorean theorem. The objectives of this topic: find the square root of a number, approximate square roots, use the Pythagorean theorem. A square root of a number A is a number B whose square is A. We use the radical sign to name square roots. In symbols, the square root of A equals B if B squared equals A. Also, the square root of 0 equals 0. What does all that mean? Well, let's look at some examples and that'll clear it right up. In A, we want to find the square root of 81. We're looking for a number times itself, a number squared that gives us 81. So this is why it's good to know our multiplication table. We have a whole diagonal of numbers times themselves. And 9 times 9 is the one that gives us 81. So the square root of 81 is 9 because 9 squared is 81. Now the square root of 1 is 1. The square root of 25 is 5 because 5 times 5 is 25. That means the square root of 1 over 25 is 1/5. Because when we multiply fractions, we multiply their numerators and multiply their denominators. And 1 times 1 is 1, 5 times 5 is 25. Similarly, the square root of 9 over 64 is going to be 3 over 8. Because 3/8 times 3/8 gives us 9/64. 3 squared is 9. 8 squared is 64. Next, approximate each square root to the nearest thousandth. This you would have to do with a calculator. If we do the square root of 58 on the calculator, rounding to the nearest thousandth is going to give us 7.616. I need some more information, so I'm going to go to my very own calculator. And if I take the square root of 58, I get 7.6157. So originally we had 6157. The 7 is a 5 or greater, which rounds the 5 up to a 6. So this is an exercise in rounding to the nearest thousand. It doesn't take any skill, well, much skill. Some calculators are tricky. Square root of 13. 3.6055, which will round up to 3.606. The square root of 89, 9.4339. That's going to round up to 9.434. So why do we need to know how to do that? Well, we're going to look at some examples of using the Pythagorean theorem. The Pythagorean theorem says if A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. Or leg squared plus leg squared equals hypotenuse squared. The hypotenuse is just the side of a right triangle that's directly across from the right angle. We can use this theorem to find missing lengths of triangles if they are right triangles, triangles that contain a right angle. So here we want to find the length of the hypotenuse of the given right triangle. We know the lengths of the legs are 12 and 16. We don't know the length of the hypotenuse. So for a squared plus b squared equals c squared, we would have 12 squared plus 16 squared equals c squared. 12 squared is 12 times 12, that's 144. 16 squared, we have to do 16 times 16 and get 256. Add the 144 and the 256, we get 400. And to get c by itself, we need to undo squaring. And we're going to do that with square rooting both sides. The square root of 400 is 20, because 20 times 20 is 400. So we know the hypotenuse is 20 feet long. Now we want to find the length of the leg of the given right triangle. So the length of the leg, not the hypotenuse. The hypotenuse we know this time. So we know C. And we know either A or B. We can use it for whichever one we want. Let's use 3 for A. Then our unknown is B. 3 squared plus B squared is 9 squared. 9 plus B squared is 81. Subtract 9 from both sides. B squared is 72. Square root both sides. B is the square root of 72. Square root of 72 is 8.4852. So we'll round that to the nearest thousandth. It's approximately 8.485. Rounded to the nearest whole yard, we could say that the leg is approximately 8 yards long. So when could this be useful? A football field is a rectangle measuring 100 yards by 53 yards. Draw a diagram and find the length of the diagonal of a football field to the nearest yard. So that plain rectangle is an exciting football field, 100 yards by 53 yards. The diagonal is what we're looking for. Well, we have a right triangle. We have 2 right triangles, both with the same hypotenuse. That hypotenuse is the diagonal we're looking for. So a squared plus b squared equals c squared. 100 squared plus 53 squared equals c squared. That's 10,000 plus 2,809. That's 12,809 when we add them together. Take the square root of both sides. The square root of 12,809 is 113.17, and 113 would be what we have to the nearest yard. So 0.176, actually it's 0.1768, so that should be 0.177, but it doesn't matter because it asked for the nearest yard. 113 yards long, not feet long, yards long. And that's the end of this topic. The topic is percents, decimals, and fractions. The objectives in this topic are understand percent, write percents as decimals or fractions, write decimals or fractions as percents, solve applications with percents, decimals, and fractions. And percent literally means per 100. Per 100. Remember when we did miles per gallon, I said that was a division problem. So something percent would be something divided by 100. Percent literally turns it into a fraction over 100. So if a basketball player makes 68 out of 100 free throws, what percent of his shots did he make? 68 out of 100 would be 68%. And that's just the definition of percent whenever we have a fraction over 100. So let's say one state produces 85 out of every 100 cherries. They produce 85 out of 100, 85% of the cherries. How about others? What do they produce? Well, if the one state produces 85 out of 100, 100 minus 85 tells us there's 15 left out of every 100 for the rest. 15%. So there's going to be a series of problems that ask you a specific question about percents. They'll give you a situation, it'll be out of 100, and you need to carefully examine what they're asking and then produce a percent. Some of them will have pie charts, but the pie charts will all add up to 100. You'll just need to add various pieces together to find out what the required percent is. The alphabet. Do we know the alphabet? I think we do. Alphabetically, D comes before P. The D is going to stand for decimal. The P is going to stand for percent. Remembering your alphabet, remembering the alphabetical order of decimal and percent is going to help us convert back and forth between decimal and percent. And we're always going to do that by moving the decimal point 2 spaces. To go from decimal to percent, we'll move it 2 spaces to the right. To go from percent to decimal, we'll go 2 spaces to the left. So if we had 63% and we wanted to convert it to a decimal, well, right now the decimal point is here. Percent to decimal is 2 spaces to the right. This would be 0.63. And that absolutely makes sense because what is this? 63 tenths hundredths. 63 hundredths, 63%. Two percent, writing it as a decimal. There it is now. 1, 2. We'd have to fill in a 0. This is 0.02. Not 0.02%. Moving the decimal changes it from being a percent. How about 350%? It's right here, right now. 1, 2. This would just be the number 3.5. The 3.50 would also be correct, but we don't need that 0 at the end. 72.9%. Writing it as a decimal, we go 1, 2, so it's 0.729. 5.1%. 1, 2, we need a 0 to fill in the spot, 0.051. 0.1%. 1, 2. We need a 0 to fill in the spot, 0.001. 900%. 1, 2. That's just the number 9. That makes sense because 100% means 100 out of 100. That is 1. 900% would be 900 over 100, which is 9. .04%. 1, 2. This is 0.4004. When you get into decimal to percent, percent to decimal, they're very quick problems. You'll get some problems where the percent you need to convert is hidden in a statement, like people take aspirin for a variety of reasons. The most common use of aspirin is to prevent heart disease, accounting for 42% of all aspirin use. What's 42% as a decimal? 1, 2. 0.42. Why are we going to the left? Because percent to decimal would be 2 spaces to the left. The alphabetical order helps. 25.8%. 1, 2. 0.258. Now let's go the other way. Now let's start with something like 0.89 and turn this into a percent. I recommend, when we can, going the decimal to percent route, just moving the decimal point 2 spaces to the right, which turns it into a percent. But you could also use the fraction middle step. 0.89 is 89 hundredths, which is the definition of 89%. .8. 1, 2. We would need to fill in a 0. 180%. The number 85. Well, where's the decimal point? It's right here. And we would go 1, 2. We would need 2 zeros. 8,500%. Because again, just because we don't see them, we need our placeholder zeros. .006 to a percent. 1, 2. 0.6. Oh, what did we change it to? A percent. This is 0.6
percent. .2712. This is 27%. 2.1. 1, 2. We need a placeholder 0. 210%. 0.031. 1, 2. 3.1%. I know we've done a lot of these so far, but why stop? These are fast. Hopefully they're giving you a lot of self-confidence. 0.9094. 1, 2. 90.94%. So some things you're hopefully noticing. The two digits that are past the decimal points, the tenths and the hundredths, they make up the number before the decimal point. Everything else comes after, and then percent. When we have something before the decimal point in the decimal form, then we have an answer over 100%. The number 5, convert it to a percent. Right now, the decimal point is here. 1, 2, that's 2 placeholder zeros. 500%. .7. 1, 2. We need a placeholder 0 to come up with 70%. If the Munoz family saves 0.22 of their take-home pay, write that as a percent. A clunky sentence. 1, 2, 22%. In 2012, about 0.237, 237 thousandths of full-time workers in a country spent time volunteering the previous year. What percent was that? 1, 2, 23.7%. 0.017 to a percent. 1, 2. 1.7%. Okay. I'm going to leave this on the screen, but make it a little smaller so I have more room. Because now we're not going to deal with just percent and decimal. We're going to throw questions about fractions in there as well. 24%, and we want it as a fraction in simplest form. Take advantage of percent, meaning per 100. The definition of percent is it's a fraction over 100. And then we reduce. They're both even. Divide them both by 2, 12 over 50. We can reduce. They're both even. Divide them both by 2, 6 over 25. %. We're going to do the same thing. That's 5% per 100. 5 over 100. 5 divided by 5 is 1. 100 divided by 5 is 20. So 120. .4%. Okay, this is going to be the first time where we have had a decimal inside a fraction. 6.4 over 100%. As soon as we have it, we need to get rid of it because we don't want a decimal inside of a fraction. Not unless there's a very specific case we're going to see next week that says do not simplify at all. But if we're simplifying, we can't have the decimal inside a fraction. So we move the point to the right until it's gone. But moving it 1 to the right on top means we also need to move it 1 to the right on the bottom. That changes this to 64 over 1,000. And then we reduce from there. They're both even. Divide them both by 2. 32 over 500. They're both even. Divide them both by 2. 16 over 250. They're both even. Divide them both by 2. 8 over 125. So 6.4% is 8 125ths. Let's take a look at 325%. Writing it as a fraction or mixed number in simplest form. 325% is 325 over 100. That's improper. Let's take it to mixed number form. 325 divided by 100. 100 goes in 3 times. That would be 3 and 25 100ths. 25 over 100 reduces to 1/4. 3 and 1/4 as a mixed number. 325% is. Let's take a look at 89%. Get me jumping ahead. 89% is 89 over 100. And for the first time, we have one that does not reduce. 62.5%. That would be 62.5 over 100, and we need to get rid of that decimal. Move it to the right till we have a whole number. That's 1 space, 625 on top. But we have to go 1 space on the bottom as well. So it's 625 over 1,000. Here we are going to need to divide both of these by 5. 625 divided by 5. 5 goes into 6 once. 5 goes into 12 twice. 5 goes into 25 5 times. So 625 divided by 5 is 125. 1,000 divided by 5 is going to be 200. They can both be divided by 5 again. 125 divided by 5 is 25. 200 divided by 5 will be 40. They both can be divided by 5 one final time. 25 divided by 5 is 5. 40 divided by 5 is 8. The answer is 5/8. So 62.5% is equivalent to the fraction 5/8. Next up, 9.75%. That's 9.75 over 100. We need to move the decimal point 2 spaces. And we get 975 over 10,000. And we reduce. Now, instead of dividing by 5, this one ends in 75. It's going to divide by 25. You can keep dividing by 5 if you want. It'll take more steps. I'm going to do a little bit harder division, and I'm going to sacrifice for time. 25 goes in 3 times. Subtract 75, we get 22. 25 will go in 9 times. Think of quarters. 9 quarters and $2.25. 8 quarters would be $2. So 975 divided by 25 is 39. 10,000 divided by 25 would be 400. I'll check it, but I'm pretty sure this is 39 over 400. It doesn't reduce any further. Absolutely. Next up, 15%. And we're doing the same thing. We want to make this a fraction or mixed number in simplest form. 15% is 15 over 100. If we reduce, divide top and bottom by 5, we get 3/20. 4 8/9%. We want to write this as a fraction that's not a percent. Remember, percent means divided by 100. So this is 4 8/9% divided by 100. 4 8/9 divided by 100 would be 4 8/9 times, flip the second, 1 over 100. And in order to multiply fractions containing mixed numbers, what do we have to do to the mixed number? It has to be an improper fraction. 9 times 4 is 36, plus 8 is 44/9 times 1 over 100 would be 44 over 900. This reduces, they're both even. Divide them both by 2, 22 over 450 They're both even. Divide them both by 2. 11 over 225. So 4 and 8/9% is 11 over 225. Look at that work we had to do to get there. We needed to understand that percent means over 100. We needed to understand that over 100 means divided by 100. We needed to understand that with fractions, dividing by a number, 100 over 1, is multiplying by this reciprocal, 1 over 100. To multiply mixed numbers, we need an improper fraction, and then we multiply and reduce. This is why we learned all these little skills along the way. Let's do another just like this. So funny how that one died so quickly. (16 7/9% means 16 7/9 per 100 means 16 7/9 divided by 100 means 16 7/9 times 1 over 100. 9 times 16 is 144, plus 7 would be 151/9 times 1 over 100 would be 151 over 900. And I would really like for that to not reduce. It doesn't. 151 over 900 is our answer. Let's write a fraction as a percent now. 7/25. If we can get it to the magic bottom number of 100, we're golden. And we can here. Times 4 over 4 gives us 28 over 100, which is 28%. And if we can't get to the magic number of 100, we would have to divide, turn it into a decimal, which then we can turn into a percent. 9/10. Well, we can multiply by 10 over 10, which gives us 90 over 100, which gives us 90%. Three-fourths. You could divide it out and get 0.75. 0.75 becomes 75%. Or you can multiply by 25 over 25, getting 75 over 100, giving you 75%. So we'll be able to use our trick for a little bit, but then we'll come across things like this. 3/8. And there is a times 125, I believe 125, that'll take us up to 1,000, but that doesn't help us with percent. Let's divide. 3 divided by 8. 8 doesn't go into 3. Give a 0.0. Move the point up. 8 goes into 33 times. 24. 6. Bring down a 0. 8 goes into 67 times. 7 times 8 is 56. Get a 4. Give a 0, bring it down, and it goes in 5 times evenly. So 3/8 is 0.375. And when we move the decimal 2 to the right, that gives us 37.5%. So we can always take our fraction, divide it like we did earlier to get the decimal, and then change that decimal to a percent. So we're not going to do a lot of these right now because we did a lot of this earlier, and then we did a lot of this less earlier. Mixed number to a percent. Let's take care of that. We haven't done one of those yet. We've done a mixed number percent to a fraction. But if we had 1 2/5 and we wanted to make it a percent, this is 1 4/10, which is 1 4/10. And then decimal to percent is 2 that way. So this is 140%. For some more fun examples. Seven elevenths, fraction to percent, round to the nearest hundredth, percent. I want to examine this direction with you. Round to the nearest hundredth percent. When we divide this out, 7 divided by 11 doesn't go in. Bring the decimal point up when we give ourselves a 0.0. 11 goes into 76 times. We get 66. We subtract. We get 4. Get a 0. Bring it down. 11 goes into 43 times. 33. Subtract. 0. Bring it down. 6 times. 66. It's happening. Oh my God, it's happening. We have a repeat. The 70 minus 66 gives us a 4. There's that repeating group. So 7/11 is 0.63 repeating. The 63 repeats. So this is 7/11 is approximately, well, it's equal to 0.63, 63, 63, 63, on and on forever. It's not approximate yet because I said it goes on and on forever. This would be the nearest hundredth, but it would not be the nearest hundredth percent. Decimal to percent would go 2 that way. So this is 63.636363 dot forever percent. And now the nearest hundredth percent would be tenths, hundredths. Look to the right, it rounds up 63.64% is our rounded answer.
So to summarize, if we're writing as a decimal, a percent as a decimal, we replace the percent symbol with its decimal equivalent, 1/100. If we're writing the percent as a fraction, we replace the percent symbol with its fraction equivalent, 1/100th. And if we're writing a decimal or fraction as a percent, we multiply by 1. We multiply by 100%. That'll give us our percent sign. "67% of American men are happy with their current weight. Convert this percent to a decimal. Write this percent as a decimal and fraction." So percent to decimal, the percent sign becomes 0.01. That moves us 2 to the left, 0.67. As a fraction, the percent symbol becomes the fraction 1/100. So 67/100. And hopefully you're catching on to these things. Percent per 100. Stick the number over 100. Decimal to percent, that's 2 to the right. Percent to decimal, like we had here, 2 to the left. An advertisement for a stereo system reads 1/5 off. What percent off is this? Well, 1/5 is a fraction. We want to take it to a percentage. So we multiply 1/5 times 100%. That's 100 over 5, or 20%. 1/5 off is the same as 20% off. And that's it for this topic.